welcome to one of the first videos here on the Self-Taught Software Engineer. Welcome to the channel. Today we're gonna look at Git as well as GitHub, and I'm gonna give you an introduction into what it is and how you use it. For the second part of using it, I'm gonna show you how to use it as on the example of IntelliJ IDEA as the environment, the IDE. Since personally that's what I'm using, and I'm also going to show you the default, like, generic way of using Git and GitHub. But I personally use IntelliJ in day-to-day developing, and I also personally believe that when getting started, this is probably the best way to do it. And also, honestly, after you got started, since if you do anyways program in IntelliJ, which I can highly recommend, outside of Git integration, it just makes sense, I personally believe, since you're using Git and coding is in the same program and it's very tightly and nicely integrated, which we'll see in a second. All right, let's get right into it. So what is Git? Right, let's start with that. So Git ultimately is a command line tool, meaning that there's no user interface by default. So it's just text-based. You just type commands and it executes them. The idea of it is to manage your versions or the history of your source code that you wrote for any language. It's agnostic of a programming language or an environment. It works on pretty much any operating system as well. And how we would describe this is a version control system, or short VCS. So what it ultimately means is that you are managing the history of how your code changed over time. You start somewhere, right, with an empty file, and develop along, adding more files, adding maybe even entire like sub projects and stuff that you all have to keep track of and manage. This gets specifically interesting when working with multiple team members, which is where Git and other VCS in general really start to shine. But even if you're just doing this as a hobby or even just getting started, of course, this is precisely why you watch it, I presume, then even then Git is very recommendable, and I'm going to explain in a second why that is. So on the next slide, we're going to look into how Git works from a high level, but let's finish this off right here with telling you that the tool was originally created by Linus Torvalds in 2005. If you don't know, this is the same guy that also created the Linux kernel in the 90s that powers most of servers and also many desktops and mobile phones with Android, of course, and is generally a very influential invention in the computing space, and so is Git, specifically for software development. So yeah, it's just I thought it's an interesting fact that you should know about, that this guy came up with two major inventions in our sector. As I mentioned, it is a command line tool, so no buttons, no yeah, you don't see anything but text. Also, the output from the tool itself is text-based. If it tells you, okay, I did this and this, just text. However, there are some popular UIs or GUIs, or GUI, we want to call it, so graphical user interface, such as IntelliJ, as we see later. Other popular candidates are Git Kraken, Git Tower, and GitHub, which we'll look at in a moment, also has its own tool. What they generally do is just put like a user interface over the command line. So in essence, if you click a button in the background, it just executes the command that you otherwise would have typed yourself. Yeah, to make it a bit easier and user-friendly ultimately. And that is also what I like about the IntelliJ integration that we're going to see in just a bit. Since not because I personally believe it's not a good idea to also know how to use the commands. I think that's generally recommendable, although I would not deem it necessarily required to get started. But some of the ways of coding and using Git together with it, in my opinion, it just works better with the user interface compared to typing a command each time. But you'll see that in a moment. And finally, what I thought I would mention here is that there's also a wide array of websites and yeah, startups, entire startups that offer some services connected to Git. The most popular option is hosting, meaning yeah, you'll see in a second what that is all about. And here the popular options are GitHub, which we're going to look at today, which you all probably heard somewhere before. We're going to create an account later. Optionally, it's not required, but I'm going to show you how and why and what you can do with it. And other popular options here are GitLab as well as Bitbucket. Even though I would consider, and I think everyone can agree, GitHub is by far the largest one. Also, the statistics, the official ones, clearly show that. And also, most of publicly available source code to help develop or contribute to, or just read or use, even if it's just software that you want to use. By far, the majority is hosted on GitHub. Other popular option, actually, now that I think of, is SourceForge, but it gets a bit out of fashion in the last few years. All right. Now, I figured it is important to have some basic understanding of what are the underlying principles of the tool Git. I will, this will not require any prior knowledge. Maybe you think, oh my god, this slide already looks confusing. Don't worry. As always with this channel, I'm gonna show you how, and it's gonna be, I'm gonna make it in easy language. The thing here quickly to recommend also is that if you haven't seen the video where I introduce myself and the channel, you can now find it in the top right corner, as well as in the description of this video, if you're interested in what else you can find on this channel and what the philosophy and yeah, the idea of the channel ultimately are. Yes. One other warning, this video does have some some audio issues. I cut out and re-recorded all the parts that were problematic. However, you'll hear an occasional crackle. Please don't get annoyed by it. I hope I hope so. This will not happen in future videos. Obviously, this is one of the first ones, and I figured out what the issue was. So I fixed it as good as possible. Bear with me, please. Yes, let's jump into the principles right now. So I'm gonna first, before we look into the diagram on the right and also the bullet points, first I figured I have to answer the question, why are we using Git ultimately? The reason for this is that we wanna manage the history of our source code, and we wanna also be able to do that with multiple people at a time. You probably all had this issue, I'm pretty sure, from either school, university, or even in your day-to-day job. I presume that's quite common, honestly, that if you work with things that are versioned in some sort, the most popular example I can probably give here are a PowerPoint presentation or a Word document or something like that. You probably all had these things that you have multiple people working on it in a work group, some environment, and you start naming the file like version 1, version 2, final version, really final version, and I'm sure many, if not everyone, went through this before in their life. And software developers quickly figured out, yeah, this is not the way we want to work, and there's probably some software that we can write to fix this issue. Sadly, this is not really super common in other things that are not software. So in Word, yeah, it's still a common problem. I know Word has like some means of managing versions and stuff, but yeah, I don't know. It's not like, I don't think super many people are aware of it and even less use it. So what ultimately the idea of Git is that you have snapshots, so to say, of your code at arbitrary points in time when you wish, such that at any later point you can track what was the history throughout the snapshots, how did the code evolve and change, and also what it offers you is an easy way to jump back in time and also forward again to any of these snapshots, also called revisions, which you see here in the diagram on the right hand side. And the beauty of this is that you cannot lose your work. There's always a nice backup of it, and you can also develop concurrently with multiple people or even alone in a way that it eliminates this problem of, oh, now we have two versions and we have to merge them back together. But more of that in a second. So that is ultimately the idea here. One quick word, Git in theory doesn't need to be used with source code. It can easily be used with any plain text. As a matter of fact, I personally and very many others use this for both my bachelor's as well as my master's thesis to track the progress, and sometimes you have like you wrote something, deleted it, and then you realize a week later, oh man, I wrote this section some time ago, but it's gone now. And of course, you can do like Control Z to undo a couple of times, but if it was a week ago, then yeah, good luck. You might find it in this versioning thing of Word, but that's not gonna help you in some cases. So Git here is perfect. You look up roughly when was this, maybe you even remember what you wrote about because it's searchable. Git, that is. And I quickly found it back and saved the day. And with source code, you have this frequently. So Git also works with any text. You can write an essay in it, a thesis, whatever. It can also work, or it does also work with like non-text-based binary data, such as a Photoshop file or something like that. It's not ideal, but people do use it. However, it comes from a source code software development background, and that's also what it's majorly used for. So the reason of this, or the idea of this, is that you track it on a different like level essentially that is hidden away. So you just write your code, and once you finished writing a piece, you can save that, let's say, and it creates a new snapshot. I think that's the best term to call it, of this state at that point of your entire code base, not just the file you edited, but the entire code base, and this snapshot then is persisted as a specific format, such that later either yourself you can go back to earlier versions. You can say if you made a mistake or accidentally deleted something. This is another common use case that doesn't even involve multiple people. That's why I can also only recommend using VCS, even if you just work on something yourself. Even then, I do it myself, and so do many other people. Since even then it's nicer to track the state of the application over time, revert changes if you made a mistake accidentally, etc. It's very helpful. Something that other programs such as Word, for example, also have, but it's like a bit hidden away. You know, there's a menu to like go back to earlier versions, but you can firstly don't decide when do I make a snapshot, and secondly, if you can get into a state where the version's too far in the back, so you cannot go back at some point. It starts overriding them, which is not the case here. So if you make a snapshot, it'll always be there. It's not going to start deleting stuff that's too old. So there's plenty of projects actually that have Git histories that have thousands and thousands of snapshots that go back, I don't know, a decade or so into the past, and you can precisely see what did the code base look like on this exact minute 10 years ago, which is, if you think about it, a very nice property that actually some other programs could also use, and sadly do not. Well, snapshot, what I mentioned now, is what you see here on the right hand side in this diagram, each of these boxes, each of the squares. Ignore the color for the time being, but what these snapshots that I mentioned are one of these boxes. To directly use the correct terminology here, this is what we call a commit. So what you do is, and the reason why it has this name is, if you decided, okay, I want to make a snapshot right now, my code is in, like, you added a feature, let's say, you added like a new feature to it, then you commit the feature, right? You commit to having finished it. That's really where the term comes from. And you invoke a certain command. We'll all see in a few minutes how that works to save that, and then it creates a snapshot, and at a later point in time, for the time being, it's only on your local disk in the folder where you're currently working in, the directory. And then at a later point, if you want to, this is entirely optional, but of course it's recommendable in case your hard disk dies or catches fire, explodes, whatever, that you can sync your local state of your repository, and that's ultimately where the teamwork comes into play. If you do have team members, you can sync it to like a centralized server, such as GitHub, which we'll see in a second. And the other people can work with this copy then. But the beauty of it is really that while I mentioned it's like a centralized server, the version you have locally and all the other team members is highly decentralized, because you can work on your thing independently of anyone else. And then just when you're done, you sync it back. You also don't have to do this every snapshot, but whenever you please. You sync it back to your server. Your team members can get it from there, continue working on it, change stuff that you did, I don't know. Such that also it is very unlikely to ever arrive into a situation where, let's say, if your server is down, which of course happens, even with no internet connection, you can continue using it, and then later, if you do have it again, you sync it back in both directions. You get what other people changed, and you can sync what you changed. And also, even if the server entirely dies, you will still have your local copy as well as all the other team members. And that is one big improvement actually over other VCSs. But that's more of a historic thing. But that was the main reason why Torvalds created Git in 2005. Yes, now a bit more technical things, and then we're going to go to what GitHub is. So Git is based on what's called a directed acyclic graph, or DAG for short, which is what you see here on the right hand side. What it ultimately just means is that you have, well, a graph, so here nodes with edges in between, the boxes and the arrows, each arrow being essentially the history from the state of one snapshot of one box to how it transformed into another snapshot, another box. And that's what this graph structure refers to. And the other things that is interesting is the directed aspect is, you can see it has a direction, so you only always go forward. This is essentially nothing else but time. So you start at the number 1 here in this case, and you add more and more features, and at some point you arrive at 9. And the idea is that you move only forward in time, so you would never add a box behind number 1 after you're already at 9, right? Because there's no reason why you would want to do this, because of course you base your the changes you did, you base on the previous changes and not the other way around. So that's where directed comes in. It's really just that there's arrows with a direction and it only goes into one direction, and that's precisely what acyclic means, or acyclic some people say. There's no cycles. That's just what that means. You cannot there's all the nodes are just connected forward, and you cannot go from 9 back to 4. If you do want to base yours, if you are at 9 and you want to go back to 4, what you do, you revert your changes back to 4. That is possible. However, that does not change your history. Once you did that, at any given moment, you can still say, oh, wait, actually, not like version 9 was actually better than the box here on the right side. I go back to version 9 and it's still there. It doesn't, like, if you revert, it doesn't delete anything. So that's the beauty of this whole system. There's this underlying directed acyclic graph that stays there, and you can jump freely around in any direction, but it only writes forward and in an acyclic fashion. That's very technical, but I thought I should mention it since it's important to know. Yes. What you can then do, as I mentioned already, each discrete code change, this can be anything. You added literally a character or an entire new file, feature, whatever. You commit, I've already mentioned that, onto the branch you're currently working on, which is the state of the code at that time. What is a branch? You see there's a lot of terminology here from trees, because ultimately it looks a bit like a tree, right? Only that it grows downward and not upward. But you also see trunk here being mentioned as the number 1 box. And what you have is that you have usually some like baseline main, also called master branch. That is the how do you say, the canonical version of your software. And then what you would usually do, and just to keep it more clean, that's really not required, but it's very highly recommended, and ultimately that's where Git shines and is used for. You can what's called branching off from any of the existing commits, or so being the boxes. What that means is, let's say we're at 1 here, so that's the state of our code. Let's say we just created our project and that's 1. Now we want to create a first feature. what you would do then, and that's also then where the teamwork comes into play a lot, is you would branch off of number one. That means you create a copy, so to say, of your number one branch just like locally on your side. And then once you developed a first part of the feature, let's say it's 2 parts to the feature, you commit this box number 2 locally, and then you add the second part and number 3. All the meantime, if you consider that this is really a timeline, that's really the important thing, the direction downward. All in the meantime, your teammates, co-workers, whatever it be, can continue developing this on their side with the version that is the canonical baseline, so to say. So they could also branch off, develop their features, and you're not interfering with each other. So you're not having this. I think a good example here is if you ever used, I guess you did, Google Docs, Google Sheets, Google Slides, all these things. And so these shared online editors for whatever. This is precisely not how Git works. And you probably had this issue once or twice, that you type something and any other person can also type over it, and then it like moves around, because if someone adds a picture at the top, then your whole screen shifts down like half the screen, because the text moves. Or if they change the formatting constantly, and it is, don't get me wrong, it's very nice that these things exist. It's very useful in certain situations, but for developing code, this would be horrible. Like, first of all, if someone changes the code to a state where it doesn't work anymore, then you can just not use it anymore, and so you couldn't execute it at that point in time. And secondly, you don't want to like jump around and all work on the same file. This is ultimately the reason why you have this decentralized nature with everyone has their own copy and they sync occasionally. You can do this like every 5 minutes if you want to. Usually you would do it, I don't know, a couple times a day if you work a full-time job as an engineer, developer. So you would branch off, your teammates can do the same, and you see in the meantime, the main green trunk can, or baseline also it's called, can develop on its own. So people can add features there directly if they would want to. It's generally not encouraged. You should always use a separate branch, but this is a bit depending on how you use Git. There's plenty of different workflows that people developed over the years. The most easy common one is though that each feature you add, you make a new branch such that your main baseline stays untouched. And then when you're done, and that's where the red arrow where it says merge comes into play, you merge it back into the baseline. You can, in general, merge any branch into any other branch. The most common case though is doing what you see in the diagram here, that you merge a feature branch back into your trunk. So branch, in case you didn't got it yet, because it is based on a tree more or less, both in the literal as well as partially, at least in the technical sense. It branches like a tree branch. So you have some branch going out, the 2 and 3 yellow here, or all the yellow boxes as a matter of fact. Then when you're done, you can merge it back. There's actually also good reasons that you do not merge it back. So what merging back refers to is just you take the changes that are now on the residual changes of 2 and 3. So 2 added a bit and box 3 added a bit. And if you like take these changes together, there's some overall change that that differs from your number 4 in this case on the trunk. This is also called a diff actually, from difference. So that what you added, what you removed, what you modified, stuff like that. And then what you can do, and this does Git for you, you don't have to do that manually. You can say, okay, now I'm done with the feature. I wanted that I'm actually either getting rid of branch 2, the branch you made with 2 and 3, or at least I want that the feature is done, so it should be in the trunk again, such that if other people start working on a new feature, they already have my feature that I added as part of it. The good example here is the boxes 5 and 6 that you see it make their own branches again. They would include everything that was in 2 and 3. That's ultimately the idea here. What you will also see is that people do not merge things back, either because it's very long running. It could be that you develop on a feature for a long time, or you see at the very bottom, the number 10, this purple box, it says discontinued development branch. So this can also happen, of course, if you realize, this feature that I started here on the 5 and 8 commits, actually no one needs that, or I found a better way of doing it in 6 and 7 maybe, let's say, and you see 6 and 7 is actually merged back into the trunk. You can also discontinue a branch. What that just means is that the changes are still there, so you can pick it up later at any point, even years later. Let's say like 5 years down the line, you say, wait, there was this one great algorithm that I wrote in this commit 100 years ago. You can still find it, and that's the beauty of Git. It's all tracked for you in a hidden away format, so it's not like you have the files actually on a disk, but it has a very clever format of representing that in a custom file format, such that at any point in time you can say, oh, open like the state of the program at commit 8, which can be very, very far, infinitely far in the past. And you can check it out and see, oh, yeah, this is nice, and copy only a bit, for example, or start to continue developing it, whatever you please. It's a very versatile system. So that also happens. The other thing that can happen is what you read maybe on the news occasionally is forking. What that just means is coming also from, there's a lot of literal terminology in general in computer science. It's like a fork to eat. You take one branch and branch it off and never branch it back. So you have plenty of examples of software in the wild that started as a fork of another software. So what that means is that there's some public open source software being, or also not open source in some cases, software being developed, and the group of developers, maybe even a single person, decides, yeah, this is a nice software, but I don't like certain things about it. You know, some features are nice, but not so nice, and I know the developers that do it now, they're not going to fix it because they think the other way is better, or they have no time, or whatever. And then what people do is just, for example, at the number 4 here, they fork it off. This is nothing else than creating a new branch. It's a fancy term for that. But what it means is that you create this copy, and what you usually do in forking, also you create an entirely new project for that, but based on this box 4 as an example, and you develop it completely disconnected from the rest. But you still usually at least would base all the history on the other projects, such that you can still see what was the history in the past, go back, go forward, stuff like that. That is the other reason why not to merge something back. Yeah, and then you can just develop, and you can see, as you can see with the 5, 8, and 6, 7 examples, you can develop many features at the site, either because you're multiple team members, so each of the branches would belong to one member, but you can also imagine that if you have features that you develop at the same time, you might work a bit on this one feature, the next day you work on the other one, and you see once you're done, you can just merge them back, and all is good. Git does take a lot of care to merge stuff in a way that is conflict free, because of course the conflict you can imagine is that if I merge something and both branches edited the exact same line in your code, it's going to have a conflict, because it has to make a decision, well, is this the version to put into the trunk, into the baseline, or is this the other one? Git is very clever in figuring that out itself. So usually very easy rules go like the one that is newer. This is a very general example, but the change that is newer is probably the one you want. But if it cannot figure it out itself, it would create what's called a merge conflict, which just means it does merge anything that is like conflict free, which is usually everything but a few lines. And then the lines that are where it cannot figure out for you what it should do, it also doesn't just merge and override stuff, but instead it asks you to like, hey, this, yeah, I don't know what to do with these 2 lines here, and then you just choose. I want this line from this branch and the other line from this branch, and then you apply, and it's done. Yeah, that's generally it. Just one quick point, you can merge any branch into any other branch. So what's also a thing that happens is that if you develop a feature and realize, oh, there's another like feature, let's say, that I need to develop, but it depends on this current one that I was developing in my already branched off branch, then what also people do is branch of another branch of that one. So let's say at the box 5, let's say, you realize, I need another feature, but I need the change that are already in 5, in the commit 5, to even be able to develop my new changes. So you would make yet another arrow that goes further away from the trunk of a 5, and it creates its complete separate own branch. You can do this infinitely often. In general, it's not really recommended to do that because you also do have to merge it back at some point, which is always, or not always, but it can be risky that then because of course the other branches move forward at the same time, so it can be that you're becoming so outdated at some point that it again cannot figure out itself what to merge, and it asks you to help it. Which if you waited very long, let's say you create a branch now and another one of that, and then the other one you only merge in a year, then it's likely that it cannot figure out everything that you want to merge, depending a bit what you change, but at least it's possible. So this basing branches on other branches that are not your master branch is generally not recommended, but there's legitimate use cases, as I mentioned. But yeah, just as I mentioned, it doesn't have to be coming from the trunk. One final thing that you see in the diagram, which I want to mention, or should mention since it's in this diagram, is tags. You don't need them super often if you start out. What this just means is that you essentially, you as the name implies, you put a tag, just like a tag in clothing or something, on a certain commit, specifying what is the state of the application of the code base at this point in time for this commit. You can tag any commit, doesn't have to be on a trunk as in the example, can be any box. What this is usually used for is versioning. So if you probably saw like I don't know, video games or drivers or something having publicly disclosed versions. Also your MS Word has this if you search long enough, or even like a Windows or something. There's Windows 8 and 10 and 11 soon and stuff. This is a nice use case for a tag, so that you say at some point the business decides, or if you develop your own, you decide yourself, this commit I'm happy with in terms of that this is the version I'm gonna bring to the public or keep private if you do it yourself. That is going to be, let's say, Windows 11. So what they would do then is create a tag of this commit where they are, and just say this is now the release version of Windows 11. And then you can write a bit of tags and stuff to like explain what does this contain, but continue developing at the same time, because of course they need to fix more things. People start using Windows 11, find problems, they have to continue working on it. So then later you would maybe release Windows 11.2 or something. There's a lot of specificity to versioning schemes, but that's what it's usually used for. But you can use it for anything. You can also use it to just mark where you finished certain features and then have them find easily in the past. Because you have to mention the commits, they do have a message always attached. So you write a short or message, which you'll see in a second, what you changed in the commit compared to the previous state of the code. But if you have like a precise like code word or text or something, then a tag is a good example to use. But they are, compared to committing, entirely optional. You never have to touch tags if you have no use case for them. This is really for proper software development, where you have versions that you release or sell even or whatever. Yeah, that's really the core principles. If there's any confusion or questions about this still, there's a lot more features to Git. This is a very basic overview. I'm gonna probably make a follow-up video at some point going into more advanced features of it, but this is all you need to get started, and also honestly also all you need in even let's say 80% of a day as a developer, even full-time. This is all you need. So let's leave it at that. Yes, but if there's a question, drop them in the comments, please. Yes, now we're looking at GitHub. So what became popular quickly after Git was released is that there were numerous sites that do this hosting part of your Git projects, Git-based projects, or your source code that uses Git to track the history. That's how I should correctly say it. Which is, by the way, called a repository. This term I actually didn't introduce so far. So just having one cohesive piece of software, so what's also called a code base usually, so one application usually, but there's you can divide it in whatever way you want it. It's called a repository. That's just a term used for that. As I mentioned, there's this optional, this is entirely optional, by the way, this server or multiple servers that you can have, where you can sync both back and forth your and get other people's changes, or simply use it for backup. If you develop yourself, as I do for hobby projects, or if you get started programming yourself, it's very nice option also to just back up your progress. If you ever lose your computer or your hard disk or whatever, it's all backed up if you did use GitHub or any other service like this on there, and your code is actually never lost, which is can be very traumatic, of course, if you spend a lot of time into writing some application or a script or something, and then from one day to another just lose it. I mean, it goes for every work, right? Photos, whatever. But in this case, there's such an easy way to back it up that honestly, it's a bit stupid to not use it. You can host this yourself if you don't like to put it on some other companies' servers. Honestly, though, this is so widely used and by so many large public companies that I don't see a reason not to use it. And yeah, as a matter of fact, my employer, for example, also uses it. So we have all our code projects on GitHub, as do very many other companies. So a nice reason why GitHub is popular is that it has very nice free offerings as well as paid options if you do need if you need it. So usually for companies, you would use a paid option if you have many employees, because there's certain features that you can only, if you have many people working on the same project, you need to pay at some point. Makes sense, right? You need to pay for the servers and all the hosting and stuff somehow. But the free option is surprisingly, nice. You can do a lot with just the free option. And if you just develop for yourself or even with a small team, there's not really a reason to use the paid option. So you don't need it. This was first launched in 2008, so 3 years after the first release of Git as the tool itself. And really the distinction here is that that Git is like the tool itself as a software essentially, and GitHub is just like an offering around it that does this hosting of your Git-based repositories for you for free, such that you don't have to do it yourself, which is quite tedious to set up manually. One word here that's I thought was nice and important to mention is this was acquired, and I actually didn't mention by whom, by Microsoft in 2018. So just to note, it's not tied to Windows or any other Microsoft product in any way. It's completely separate. It's just like a subsidiary. But yeah, they acquired it some time ago, and yeah, honestly, I'm using it for quite some time longer than that, and nothing really changed. The only thing you see, which I gotta say is positive, they develop new features way more quickly since the funding is better now, obviously, because Microsoft has a lot more money than the startup that GitHub was beforehand had. So there's a lot of new features recently, but in its core, it stayed the same even after the acquisition. All right. Now we're gonna look into actually using Git together with GitHub, and we're gonna use this in IntelliJ IDEA. So again, if you have never used that or don't even have it installed, then I suggest watching this other video that I mentioned in the beginning and that you'll find in the description of this video, where I show you how to set it up. Before we do that, however, we need a GitHub account, obviously, otherwise this is all a bit useless. So what we're gonna do is, but okay, one thing here I have to mention, this is optional. You don't need it. You can work perfectly fine, and I'll anyways always have chapter marks in my YouTube videos. You can just jump to the next chapter that probably says something like, using Git in IntelliJ or whatever. If you want to skip this step, you do not need this account. The really reason that it's nice is to get acquainted a bit with it, because if you ever consider a career in software development, then you very likely wanna or have to have an account. It's free of charge, as I mentioned, and as I said, I can also recommend it for backing up your own work, even if it's hobby work. but it is optional. What we just do, I'm not going to do this now since I obviously have one already. You go just to github in one word.com, and then there's this sign up button up here with this very nice looking website, and you can run through this very well done sign up sheet and create an account. As I said, I'm not going to do that now. But what we're going to do now is quickly show you the user interface. So if you created an account, you will see something like this. There's your account here in the excuse me, in the top right. And I'm quickly going to show you some show you around very roughly what are the features that you need. Obviously there's a search here. So what GitHub is ultimately also popular for is hosting publicly, code publicly. So you find millions and millions of large projects that are open source, so where everyone can view and also maintain the code that they're hosted on GitHub. Let's just do the following. If we actually search here for IntelliJ, then and go to we're searching in our own org, search all of GitHub. Then you actually see that JetBrains, the company, has IntelliJ community. It's hosted here, so you can, if you're interested, you could just go here and look at the code, and that's ultimately what one of the nice things about then you can get the entire look at the entire program. One of the nice things that it's used for. There's a lot of other features here that you can make use of. This is essentially just a file browser. Here's a small README that many projects will have, where it explains how to use it, how to work on it, etc. You see here the contributors, so people that contributed code to it. There's a lot of people in this case, 688. That's quite a lot for a project publicly on GitHub, but pretty cool to see. So it's developed by many people, not just by JetBrains. That's ultimately the idea of this here. The other thing that you'll have here, which is interesting to see, is if you click this button here, you see all the branches, and you can also search here what you saw in the diagram earlier. So they have apparently each feature they add has a number, as it looks like, some ID, and so each branch is one ID. So now you can actually see what I mentioned earlier. You can go to a random one, and now the state of every file you would open now is at this point in time. Usually I would give you branches, if you do this locally or if you do this yourself, some more telling name than just a number. This is usually because they also track the exact feature somewhere, and then it needs an ID. It's a bit more useful. But usually I would probably name it then, like a rough description, what the feature's about, with hyphens in between or underscores or something. But what you can see here is this branch is 2000 and whatever commits ahead, and so many commits behind master being the trunk, the baseline branch. So you see it is in a certain point in time. What you can actually do to have a bit of a better understanding of this, I'm rarely doing this, but it can be quite nice if you go to Insights, and commits, no, depends, network, sorry, network, that was it. You see, you see this, what you saw in the diagram, you see here live with actual data. So you can see where something branched off. You actually also see forks. So you see user @stone here, which is just someone with a GitHub account. They they forked IntelliJ at this commit and created their own version. Maybe in this case he added something, optimized images, and you can go back here and see the whole history. So there's quite a lot of people, well, actually very, very, very many people that forked this and added something or whatever. And then what you can also do is you can put it back into IntelliJ, the main version. What that is you see here as a pull request. I'm not going to go there now. What it essentially just means is that you ask, as in this case, Toshiaki Kameyama, you ask the IntelliJ, JetBrains people, hey, I developed some feature, in this case here, convert concatenation to template, blah, blah. He added something. are you interested in having this in your own, in the main trunk, right? The main branch, master as it's called here, such that it becomes part of IntelliJ. So next time you update it, you might have this feature of this guy in there. And that's a pull request. So you ask to pull this branch back into the master branch. That's where the name comes from. A few other things that are interesting to see if you want to use this code, you can go here and download it either as a zip file and then open it in IntelliJ. Or the other thing that you can do, which I'm quickly going to show you, is if you go to IntelliJ Toolbox Chrome, there's a Chrome as well as Firefox extension that you can install. And I hope that I don't have to restart Chrome now. Apparently not. That's good. And what you have then, if you refresh this page quickly, is have these buttons here, or this button in this case, that says clone in IntelliJ. And what this does, if I click it, I'm not going to do it with this example because otherwise I clone a lot of stuff. We're going to do it in a second though. It downloads automatically and opens the right stuff and so on of whatever repository you have in front of you. Cloning, just so you know what that means, it just means having like the version, like syncing this remote version to your local disk and having it independently from there. So this would also mean that if they decide to delete this entirely or make it like private, you still have your local version. So that's why it's cloning. You essentially copy it one-on-one. You can also use this option though and download it just as a plain file if you prefer that. The final thing I should mention here is that GitHub also acts a bit as a social network for software developers of sorts, such that you have a few features such that you can, for example, here you can star, so favorite or whatever you would call it, projects. Here you can see the forking that I mentioned, and you can follow other users. So if you go here on this icon and say your profile, you get to in this case here my profile, and you can have like a small description and some. It's a little bit like Twitter or something, and you can see here I have 39 followers apparently, and I'm following some people. And you have also, if you go to the main page, you have like a news feed of sorts. So you see what other people posted somewhere, what other people added new features to, released a new version of something. It's quite nice, and it's a very, very niche social network, but it's quite interesting at that, and it works quite well. What you see here on your own page is some projects you did in the past, as well as some overview of how much contributions you had in your or other people's projects. You see I have something almost every day since I code a lot and also do it as a full-time job, of course. And yeah, you can find other people here via the search bar and follow them. There's many popular like public figures, of course, of GitHub of course as well, that develop some popular program or something, and you can follow them and track them and message them or whatever. So now we're gonna jump into, after hearing all the theory and maybe haven't set up the GitHub account. As I said, it's not required. Let's look at how to use Git and also GitHub actually from within the IntelliJ IDEA environment. You can, in theory, probably follow along with the steps that I'm going to do now if you do not use IntelliJ but some other coding environment. However, I can recommend to use that. And as a matter of fact, check out the other video that I have on setting up IntelliJ itself, which you will find in the description of this video. Nevertheless, the following steps you can also follow along, albeit maybe it's a bit more abstract with any other environment, and also the command line, of course. All right, let's get to it. So let's open IntelliJ. I already did that. If you do not have that, again, the pointer to another video that I have where I show how to install it and set it up in the way that we have. As a matter of fact, what you see right now here is the final screen from the other video that I recorded earlier, where we set this up, what you see here. So when we're here in IntelliJ, it comes with a integration for Git and also GitHub actually, as well as other VCS. But as I said, GitHub by far the most popular option, and we're going to use that. And I would also recommend to do that if you're getting started. So the first step that we're going to do is you need some code here, or it doesn't even have to be code, some file that you have. You can just create an empty file by right-clicking new and create a Kotlin file, or honestly just an empty file here. It doesn't really matter, and name it anything. So that's our starting point. Then we're going to go here on VCS. Now you know what that means. And the first option here, enable the integration. Right. It's going to ask us what version control system we're using. We're using Git, of course, so we just leave it on the default. And then what's happening now is two things. Firstly, we see here it says created Git repository in our path here. The second thing we see is that we now have one of these tabs that I explained about in the other video. So we can also move this around and whatnot. I'll leave it here for now. And finally, what we see is here the colors of the files all change to red. Do not worry, this does not mean that your file contains an error. It's a bit confusing, honestly, because if you have an error in your file, let's say I write something that just doesn't make any sense, the text here gets red, but the file gets like squiggly lined underneath. So that's an error. If the file name is red, that's just your VCS tracking. Right. So what happened now? We created an empty Git repository. All that means is that locally, not yet in any server, we are tracking our changes, or we can now track our changes anywhere in this directory on your computer using Git. And now we're going to look into how that works. The first thing we're going to do right now, which you can skip if you did not create a GitHub account just earlier, then you would just skip this step. So the first thing we're going to do now is connect our local version here with the synced version on GitHub. Don't worry, this will not be publicly on the internet if you do not want it, but that's the first step we're going to do. Just a quick reminder, because otherwise the state will later be that you cannot easily follow along anymore. If you did not create a GitHub account or want to use any other Git-based hosting provider, then all you have to do in that case is directly click here on the commit option. For everyone else, that comes in a second, and select everything here and do a first commit. I will show in a second how this works, and just click here on commit then. But at that point, you will be in the same state as what I'm showing now to set it up with GitHub. So if you did create a GitHub account, then you can ignore what I just said and follow along. For everyone else, jump ahead to the marker in the chapter of YouTube where we look into how to use Git once everything's connected or not. All right, so what we're going to do first is you go on Git here in the top menu bar, GitHub, and then you say share project on GitHub. What this does is it will create, or it will do two things. It'll create a repository, a project in GitHub, and it also will make it, it will sync it with your local changes here. So for you, if you work on this just for hobby reasons, by yourself, not with any teammates, the major advantage, as I alluded to on the slides earlier, is that firstly, you have a backup always. So even if you lose your computer, it catches fire or whatever, it's still always, as long as you're synced, will be on GitHub, and you can just restore it in the same way. And also you have the entire history at any time, which can be pretty helpful, as you hopefully saw. If you are on this window, it might be that in your case, you're not logged in yet. You saw earlier for a second it said like fetching information from my GitHub account. There is an option down here if you're not logged in to log into GitHub, or actually any other hoster, or not any other, the ones that IntelliJ supports, which are a few others as far as I'm aware. And then you just have to click log in here, and it takes you into the browser and you log in, and then you're at the same screen as I am right here. So the first thing we'll do is we're choosing a name for the repository. I'm just going to use this here. So the self-taught software engineer, put here whatever you wish. If it's just anyways an example and you don't have a concrete plan yet what you want to program, then I would probably just start out with example or something like that. Actually, let's just do that. Then this checkbox, you can decide if your code or your content here will be publicly available on the internet, also meaning you can find it on Google and on GitHub itself, obviously. If you do not check this box, if you do not want that, just check this. In this case, it's private. Only you can see it. Anyways, if you keep it public, that does not mean that other people can edit or modify it. It just means it's a view-only thing. You still decide for both private as well as public who can edit it. And by default, it's just yourself. But you can, if you do have friends that you want to code together with or teammates, you can later on GitHub enable that certain accounts can view it if it's private and even optionally edit certain parts or everything. Right, the remote here, please leave it on origin, otherwise we're going to have a lot of problems later. That's just the default and makes sense to leave it at that. What it just means is just the internal name of the remote server. This is not a URL or anything, it's just the name, but this is the default, and yeah, if you change it, you might have a bunch of problems later. Description, this is optional. You can put some description of what you're doing here, so I'm gonna put this is just an example. You can leave it as empty. And now we click here on share. And what happens now is that we're getting this window and it tells us to do a first commit. You know what a commit is now, of course. In this case, we're just gonna, as I showed for the people that did not create an account, you just leave it checked here on anything and you choose a message. Initial commit is a good message since that's what it's about. So honestly, we're just gonna click on add. Right. What happened now is that it says successfully shared project on GitHub, but what happened also in the back is, as I mentioned, it executes the commands you would otherwise type into your terminal, a text-based interface. It just executes them in the background without you seeing it. So it doesn't do any magic here in IntelliJ, right? It's just that, for example, right now, if we did commit, it does a few separate commands that you cannot see, but in the end, it just uses the Git interface. So it's a wrapper, you would call this also. Right. What we are going to do now is you go here in the bottom on Git and on log here, the tab. Because what you can see here now is essentially this tree that we saw earlier in the diagram. It's starting to form here. In this case, it grows in the other direction. So there will be new things at the top. But apart from that, it's the same. So we see we have one commit. And what you can see then here is if you go onto it, you see a few things. You see who created the commit. You also go away. You also see that here. You see a precise timestamp when that happened. And you can see if you scroll around here, you see what was part of the commit. The final thing I want to show here that is very helpful. Honestly, I can recommend to just look at what these buttons do, but the only one we need for now is if you go on one specific file that was changed in the commit and click this comparison button here, then you see what was actually changed. In this case, everything is green, so the entire file in this case was added, all of its contents. But of course, if you later modify, like remove a line, for instance, it would have a different color and would look differently. And you would also see the version before and after. In this case, there's no before, so it's only a single view. I'm going to show you what I mean in a moment. Yes, you can search here for anything really, authors, commit messages, whatever you want. And the other thing that we're going to look at now is how to use Git itself, because so far we didn't do much, right? So the first thing, I will hide this, you can also leave it open. The first thing that is important to know is what branch are we on? You see this, it's a bit hidden, but it's in the bottom right corner here where it has this icon that also looks like a branch. And also the Git icon looks very similar. And it says master. So this is the trunk that you saw on the diagram earlier. This can have any name. A common is to name it master, but it doesn't matter. You can actually rename it if you would want to. And so that is the trunk. That is the canonical thing that I mentioned earlier of your code. And then what you see here is that you have both local branches as well as remote branches. Of course, local just being here on your computer, and remote being, in this case, on the GitHub servers. In my case, privately. If you did the same, then just hidden and only you can see it. But here it is. And then also you see this origin / and then the name, as you might have guessed now, just implies this is the remote version, and without anything, it's just the local one. Right. We can switch branches here. Currently, we do not have any branch, but in the moment we'll create one. All right. What we're going to do right now is, if you created a file, an empty one, and committed that, and even if you did not, you can just create one now. We can start editing stuff here, and I'm going to show you a bit how Git is integrated into IntelliJ. So we can do a few things. We can go here and add another line. So for example, I'm going to add here number E is I don't know, 100. What you see now is that in this margin right here, there's this green bar right now, which shows you which lines were added. That's the color green. So if I add another line, doesn't matter what, the bar gets longer and longer. This is also called a hunk. So this is one like connected change, so to say. The other thing that you notice, apart from the fact that the file now has an error, is that the file name, both here as well as in your selection here, gets blue. Blue in this case means the file was modified in any sense. So this could mean something was deleted, something was added, something was literally modified, so the line was just changed. Can mean anything. That's the blue color here. The other thing that we can do is, if we go here and say new file, either file or a Kotlin file, and call that example 2, for instance, it asks us, do you want to add the following file to Git? What this does, and you can also say like, just do this as a default, which usually makes sense. What this does is that if you do this, the file then becomes tracked by Git, meaning that if you make any changes, it'll ask you by default when you commit that these changes are part of the next commit. You can of course set that aside, like this is part of it, this is not, but at least the file itself will be, the changes will be tracked. If you press cancel here, it's just a file on your disk, and it's just ignored by Git as if it wouldn't be there. You can still use it to code, but it will never show up in any Git history, and also never on the remote origin server. I would advise you to press add, but I'm gonna do cancel just to show you how you would add something later that you didn't do via this window, because otherwise you're very reliant on this window popping up. So if they ever change it, you're a bit lost. So that's why I'm gonna do cancel for now. What you see now also is that the file name is red, as we saw when nothing was tracked. So if you now right click on the untracked file here and go to Git and then to add, you also use this shortcut, of course. Then this file is now tracked by Git, which you can see by the fact that it's green. Green, of course, being since it's newly tracked, and it has no history yet. It starts from nothing. That's why it's green color. So blue is modification, green is addition, you could say. Right. What else do we have here? So we can also modify a line. So if we change this here, for example, to 32, then you see this also becomes blue here at the side, indicating that the line was there before, but it was modified in some way. This happens already after you change anything. So even if I add a space bar here, actually in this case it thinks it's new, but if you modify a single digit here, it'll tell you, okay, it was modified. The other thing you can obviously do is delete a line. So if we go here and get rid of these first two lines, you're gonna get this triangle here. I would maybe call it, which indicates you something was here in the previous commit, but it's not anymore. Of course, they didn't make this a color red, for instance, because there's nothing to make the color on, right? Because the line is gone. But that's this triangle. What you can do now, and this is the one of the nice features I alluded to earlier, is you can go back and forth in these changes. So what you would usually do if you realize, oh, I deleted this line, damn, I would, of course, if it's just a single change, you can just do undo. But otherwise, what's very helpful, this works with any of these things here in the margin, by the way. You can click on the triangle and it shows you the change in this small pop-up. So you see a few things. You see what was the content beforehand. In this case now it's nothing. What you can also do is jump with these arrows like from change to change. In this case we have just 2, so the deletion and here the addition of the line. And finally what is very helpful is you can undo it. So this rolls back the change. The final thing you can do here with these are the button you already saw earlier. You can show like a more fully fledged view, like in the whole context of the file, what changed. Is pretty helpful for larger changes. For a small one, as in this case, this small pop-up usually is fine. So let's say we did this accidentally. We just click on this button here or use the shortcut and boom, it's back. And we didn't have to specify precisely what we want and not and so on. Same we can do in the other way around, of course. Let's say, oh, number E, we actually don't want that. You click on the green box here and you revert it and it's gone. And what you also notice now is that the file name went from blue to, again, like default white color or gray or whatever, such that it is not modified. So in the previous, as is in the current version, the file didn't change. This for you, once you start programming, is very helpful indication, because later on, if you open all your files, let's say you have more than just 3, you have a very you directly see with these colors in here, and even better if you open a file with the colors in the margin here, the gutter you would also call this, you see what was changed actually, and you have a better understanding. Wait, did I mean to really change this, or was this accidental, or should this file really change? So if you're later looking into more engineering based topics, you can also then ask yourself, if you intended to add feature X, but you change the file where you think like, wait, this doesn't have to do anything with feature X. This is a very good indication to tell you like, okay, maybe I changed it at the wrong place, or I did some sort of a mistake, or it can be improved in some form. So these colors are really nice and helpful. Right. What we're going to do now is commit something. So we're going to go back to adding number E. And we're going to commit the change here such that, well, first of all, we kept track of it. We cannot lose it anymore. And we're also going to sync it back to the origin, in this case, GitHub. Of course, the syncing is optional. If you don't have the account, then you just keep it locally, which is perfectly fine. What we do is we click, as you saw earlier already, on this check mark here, or do Command K, or the alternative for Windows and Linux. And it either will open like a pop-up here on the side, which is probably if I go here to switch to tool window. Yes. So this is likely going to show here at the side in the newer IntelliJ versions. I'm personally not the biggest fan of it, because you don't easily see what was changed. So I'm personally liking more the commit dialog. You can switch back and forth here, but if you're fine with this, then go ahead. So I prefer for this one, since I see the files that changed, I can type a commit message and I can see also what changed. So if you select different files here, you see the what's called a diff, the difference between old and new version. Now you can like enlarge and make all the boxes here smaller, as you would know it from any other program. So usually what I would do is make the it's a bit hard to hit. Here we go. The commit message quite small, since you're likely not gonna type 10 lines here, and the diff usually quite large, and this also a bit smaller. Of course, you can also maximize it or whatever. So what we're gonna do now is also learn a bit how to commit properly. It's sort of a science almost. There's very many different people doing it differently. What I generally can recommend, of course, is to commit in like concrete, cohesive chunks. So what I mean by that is, if you, in this case, a good like division, let's say, of the commits in this case would be, we first add our commit our changed file, and then maybe the change we did in this other file. This is optional. This is up to you. So actually, now that I'm saying it, it's more of an art than a science, actually. So you have to decide at the end what you're doing. But that's what I would recommend. And then what you do here for the message is you make this in imperative form. At least that's what most people do. So in this case, we would say add new file. This is not a specifically good message. Don't do that. Describe what file you added. In this case, it is an example and it contains nothing. So at least we could say example file maybe. So what you do here is you describe the change. This can be as long or as short as you want. In general, aim for a short, succinct message that just tells other people as well as yourself in a week or a year from now what was meant by that. But I would keep it short. No one stops you from writing more. Sometimes it also makes sense if it's a larger change, a big change. But in general, I would keep it simple. That's it. Yeah, you can select here what files you want to commit. And what you can also do actually is you can even only commit certain parts of a file, these hunks that I mentioned. So if we would have multiple changes here, I could just, there would be more than just this checkbox. I could also just say, I only want this line, but not the deleted line. In this case, I undid it, but you get what I'm saying. So that is also very helpful. If you have a file where there's 10 changes, but in this commit, only that one should land, then this is perfect for that. For now, we're only going to use this. So the message is there, and then you just click on commit. This takes only a second, and it also confirms that it did here. And now you see the file number 2 is white color again. So it's the same as in the previous commit. The previous now being the one we just did. So what we can do now is what's called pushing, or what I earlier called syncing between our local and the origin copies versions. We do that by clicking this green like upwards pointing arrow, so we push into the cloud, or whatever you could argue. So that's where the terminology comes from, or this is the shortcut for it. And then it would give you a list here of your commits. In our case, we only have a single one, and it says I'm going to push from local master to the origin master, which you saw earlier. You also see all the files that changed in general, so not per commit, but if you would have 10, this would be everything that changed in general. Again, a nice overview to see if you're committing what you're pushing, what you intend to. And then we just click push here, and it takes a few seconds because now this of course uploads your change into the internet, and there we go, it's done. So at this point in time, if you would throw away your computer and shred your hard disk, the change, at least the first one here, which we can also now see if we go here on log, we have 2 commits now. This is backed up by GitHub, and it will, I mean, as long as GitHub does exist, it will not go away, which is very helpful. Because of course you might lose your data at some point. Ideally it doesn't happen, but no one's safe, I guess. Right. The next thing we're going to do now is also commit this, and then I'm going to show you how you can change a commit afterwards, since sometimes that might happen. So you already committed something and then you realize, oh man, I made a mistake. Of course, what you can always do is just do a change again and commit over it, so to say, like just override it again with a new commit. But of course, at some point you accumulate a lot of commits which you might not want. It doesn't really hurt, right? It's there for free. Doesn't matter if you have 10 or 10,000, but yeah, if you want to keep it clean, then knowing how to undo it is quite helpful. What we're first going to do, I realize, since that's something I have to show you anyhow, is using other branches, as you saw in the diagram earlier. Another thing quickly before that is, this is of course not relevant right now since there's no one else pushing onto our GitHub repository, but this other button will at some point also be important to you. This is called pulling, or as they call it here, update project. So you pull the changes that are already synced into the cloud on GitHub into your local project, and Git will make sure to merge them, as I explained earlier. You can also use Command T, so let's do that right now. It will ask us if there are changes, how do we want to like merge them. Honestly, to get started, I would leave it on the first option since that's the more intuitive one in my opinion. But if you want to read more about it, then make sure to Google Git merging or Git rebasing. Yeah. Again, here you can say, don't ask me again. So if we say okay here, it is pulling, but now it says all files up to date, since obviously there's no one else. But of course, if you do work with multiple people, you need this at some point. The thing here to note is that you can pull or push also at any time. So you don't have to push after every commit. Some people do, some people don't. It's not really, there's no rule really. you can push and pull at times that are convenient to you. So what you would usually do is you would do a few commits, and then when you're done with your work, you push. You can also do it after every commit if you're afraid that you might lose your local work due to some problem. And pulling you would usually do if you are done with your local work and you want to get the changes from the other people. But here, what you should be aware of, I would suggest to do pulling at a point in time where you have committed all your local changes, because what you run into otherwise is that it might run into merge conflicts that we quickly talked about earlier, and then you have to resolve them while your work is not backed up yet, and that can be potentially very annoying. So ideally, I would pull at a point where it's convenient for you, so not every 10 minutes or so, but just like, I don't know, when you really need to. There's no use otherwise if you don't expect any changes to just pull because you're feeling like it. You can, of course, but it's not really required or necessary. Right, let's change a branch now and just create a new one. So if we go here on, click here where we see that currently we are on master, we can go on the master branch here and say new branch from selected. So what this does is what you saw earlier, it branches off of the current point in time of master, being our latest commit that we just did, and creates a fresh branch. You give it any name that you want. For now, let's call it testing. I don't know. This is usually you would call a feature. So let's say we add, we have summation here already. So add multiplication. This is some proper name that you would probably give it. Or what many people do otherwise, as you saw in the IntelliJ thing, give it like some ID if you have some external tracking system. Let's actually pick that. You just say create, and it also already checks out the branch. Checking out in this case just means changing your local setup or local state to this branch. So now you see we are on add multiplication. You can always go back at any time. You can go here again on master and say checkout. And now we're again on master, but let's make our commit here on the new branch. And now since we said to add multiplication, let's actually do it. Yeah, this a lot of space here we actually also don't need really anymore. So just let's add a new, function that's called multiply. This is not required, of course. I'm just doing some extra change because it's a bit more interesting to see how you would actually apply this. And then of course we just do a multiplication here. And let's also make sure to use it. If you want to know more about all these shortcuts here that I'm using to quickly edit, this is going to come in a more advanced video about how to use IntelliJ efficiently. So make sure to subscribe to not miss that. As you can see, it's very helpful. And there's a lot more things than just doing this. All right, let's, I don't know, multiply numbers C and D, and let's get rid of this one. Let's say this is our change. We added this thing and the function and got rid of all the white space here, all the empty lines. All right, and we are on our feature branch. This is generally how many people use Git, as I mentioned earlier. Make a branch for a new feature and then merge it back into your trunk, master in our case, once you're done. So we commit and we say add multiplication feature. Yeah, whatever. There's a bit, as I said, over time you'll find how to write good messages. Just keep at it. There's not really a wrong and a right, but yeah, keep it to the point and descriptive. That's all I can give as a tip. And then we commit, and then we can see here that we now have our other commit. And what you note now is that you have you see, although it's not super visible maybe here, that you now have this multiple branches. So you see that here that master and also the origin version of it is on this commit, while your local, and there's no origin here, you see, because we didn't push yet, your local add multiplication is on this new commit already. So let's push now into our new branch that we added here. It also says now here new, because it doesn't exist yet on origin. Then once that is done, you see it now says origin and add multiplication, which is a bit of a weird way of saying we have the add multiplication branch and the origin version of it, so the GitHub remote version, is on the same state here. You also see all these like small tag icons that tell us that. Right, now let's do a merge operation. And I think then we're almost already done. I'm going to quickly show you how to undo something or change something after the fact. And then I think we're good to go. Right, so usually what you would do is you would go to the branch that you want to merge into. You don't have to, but it generally makes a lot most sense. So you go into, you go back to your master branch in this case, and now you see, this is really, now really it becomes apparent where the branching is powerful. Our change is not here, right? We only have the sum function, we have all this white space, we have these unused values here, because it automatically on the fly changes. So whenever you switch between the branches here, it's instantaneous, like boom, the stuff is back, you know? So that's very cool for like keeping multiple working different versions, let's say, or in this case for features, it's perfect. Now if you want to merge, you can go here on the selector for the branches, go on the branch that you want to merge into yourself, so to say, into your own branch, click on it and say merge selected into current. What this of course means is selected, meaning the one that has the blue background here, and current, the one that you see in the name at the bottom here that you're currently on, so to say. That's what this is supposed to tell you. So you say merge, and now it merged. And what it also will tell you now is, I merged it, do you want to delete the other branch? Which in most cases makes sense, since now you don't really need it anymore, right? Because the change, as you can see, is now also on our trunk baseline branch. So in this case, I'm going to say yes. You don't have to, but you can if you want to. It will also now ask me, I deleted the local branch. Do you also want to delete the tracked, which is yet another term. Don't ask me why there's so many terms for the origin version of add multiplication. You can do this if you want to keep it clean, but of course that means that if you ever want to go back to something specific on that branch, it's going to be gone both locally as well as on GitHub. So maybe to get started, I wouldn't do this, since that's such that you can always go back to other parts. So I'm not going to do this right now, but you can if you want to keep it clean and only have the features that you're currently working on, or the branches that you're currently working on, both locally and on GitHub or any other hoster. Yes. So now you see it merged. All the files are just the default color, so no open changes, which is also called staged. So if you have a change that is locally but not yet committed, it's called a staged change. What I'll quickly do now is we're gonna commit something and then undo it, since sometimes that might be helpful. So what we do is accidentally, let's say, delete this function. That is a bit of a stupid example since everything lights up red since we have an error, but let's say that's what we're gonna do. And we say add the vision feature. Let's say we made a grandiose mistake and just thought we added something and actually we didn't. Or actually what we can do to make it a bit more interesting is that we add here divide. Actually, let me copy that, otherwise I write the same stuff all the time. Divide, and here we divide, but we also accidentally deleted multiply because we were sleeping on the job or whatever. And we said add division feature and forgot also to see it here. Of course you would see now, right? We added this, we removed this. That's what this is supposed to tell us. It went from this to nothing, and it's also gray color. But let's say we already did that now, it's too late. It'll tell us also, oh, there's a problem in here. So IntelliJ, ultimately, honestly, that's also one of the reasons what's so nice about it compared to using Git outside of IntelliJ or the command line interface. It even tells you the file blah 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 contains problems. It's even more precise. 1 error and no warnings found. Are you really sure you want to commit? And as a matter of fact, the default option actually is review, which will will bring up a nice window that shows you what the problems are. And you really have to confirm to it, like, yes, I want to commit this, even though the code is fucked. So let's do that. And now you realize later, oh, then what did I do? I already committed this now. What you can do now are a few things. In this case, if it's just the latest commit, the easiest is you will have here the option undo last commit. This is specific to IntelliJ. You can also do this just with Git, but in IntelliJ it works specifically nice. The other option is revert commit. What that does is it not just undoes it, it essentially just does the negative, so to say, the opposite of the commit you want to revert. So it adds another commit on top of it that just does everything that the reverted command did in reverse, so to say. So in this case, it would add our thing back. But it does add another commit. So if it's the latest one, I would honestly use this one because it just literally gets rid of this commit. Your changes are staged again, so you have your stuff back, and you can just do a new commit with a proper message and proper content. Yes, the other option we have, in this case, it's not really helpful because we also will lose more than just our lost multiplication function. Is you can click on any previous commit in here, right click that is, and say reset current branch to here. Now there's a bunch of options here where you can choose. What happens is it changes your local state to the point in time or to the state of this commit, which would of course get rid of this one. And there's a few options. The two ones that make the most sense to use for you probably are mixed, which means that it just it changes it back, but it doesn't change your files on your disk yet. It just you will see the changes and be able to commit them again, for instance. Or which also it says here, warning, it's a hard reset. What that does, it really overrides all you had in your file and makes the exact copy of the file you had at this point in time. So use this with a bit of caution. However, it can be very helpful if you made some mistakes and you really just want to get rid of it outright and go back to where. If you're not really sure, do I still need my changes here? Please do not use hard. That's why the warning is here, because if in doubt, it will delete something. We're not going to do that now because undoing is way easier right now. We could do that, but let's do undo. So you go here and say undo, and now it asks you what change list do you want to put it on. This is an IntelliJ specific feature. What it just does is you can keep your changes in multiple lists. Yeah, that's why it's called change list, right? Such that you can, if you have let's say you develop like a sub part of a feature and another one, you can keep them in multiple places and later commit them. It's a more advanced feature, so for now you don't really need that. So you just click OK here. You can keep the name, it doesn't really matter. And now you see we're back where we were with the change still applied, but also you see we have these nice icons back, such that now we can just easily, as you saw earlier, click or not, yes, click on this arrow here and say, give us the multiplication function back. And also we realize, wait, this is not used. So we're also just gonna, we're gonna use divide now as well. So now we see, this is what we ultimately wanted to commit in the first place. So, so let's do that. And then we can say at division feature, this time it's all correct. So here we go. And here we are with the correct change. Yes, that is pretty much all you need. You will now, of course, would have to push again if you would want to have this tracked by GitHub and backed up also. The last quick thing I'm going to show you, since it can be very helpful, is what's called stashing or shelving. What that just does is we're going to do it on the example of a subtract function. Oh, why am I keep doing this? I can just take this one here, subtract, and it does this. And we're also going to use it here. Oops, want this. No, we don't want this. Sorry, we want this, of course. Subtract. Yes. And now you do run into the case occasionally that you have a change and you know you will need it later, but you don't need it now. Also, a common reason for that is that if you need to change your branch to another branch, for example, to get someone else added multiplication for you, let's suppose it's not already there, and you want to check that out, both literally in terms of checking out the branch as well as checking out the changes. What you usually, or what can happen, of course, is if someone edited the same line as you did, for example, this one, you might already have some conflict by just changing a branch. That can happen because, of course, Git needs to display, or IntelliJ and Git in the background needs to display the changes here for you. So if you have open changes that are uncommitted and you change to a branch, if there is a line that was edited in both, you might have a problem. So before you change a branch, I can then thus only recommend to either just commit your changes. That's honestly the best option. Even if your feature is not, no, come on. Even if your feature is not entirely done, just I would still commit it and call it maybe part 1 or something like that. Or the other option that you can also do, if you wanna, if it's a larger feature and you just started, or you really want to keep your commit history clean, is stashing. What that does, it just takes your changes that you have and it temporarily removes them from the file, but it keeps the changes in the exact format you see here. So if you undo the stash, or it's called unstash, it's also called, it's in the same state as beforehand. So this is a nice way of like acknowledging I will need this later, but right now I need the file to be in another state, for example, for changing to another branch. So I'm gonna temporarily store them away and later get them back. How you would do this is you would, well, there's many ways to do it, but you can go to Git and go to uncommitted changes, which is what this ultimately is. And then it has this option, option stash and unstash. What you would do then here is yeah, you save it and later take it back. However, since we're already using IntelliJ, what I can recommend you doing is using this shelf option with this small downward arrow icon instead. What this is it's an addition by the IntelliJ developers to make the stashing and unstashing a bit more easier. This internally just uses the stash functionality of Git, but it adds a bit of nice features on top of it. So personally, I only always use this and not really stashing. However, at the end of the day, it doesn't make a huge difference. But I would recommend you to use this since it's a bit more ergonomic or whatever. So if we do that, it asks us, and you notice this looks actually just like a commit. The only difference is that here it says shelf changes, and it looks a bit like a commit. So you can already choose a commit message for the future. Don't worry, of course, this will not commit anything. Just save your changes away and clean up the file, so to say. So in this case, we can just decide already on a message and use it later. You can leave this empty. It doesn't make any difference at this point. It's just also later, if you have, let's say, 20 shelves or stashes, it's easier to see what does it contain. That's also another reason to put this. So later, if you have many of these saved away, of course, it's nice to see, this was the one where I had the subtraction. So you just then click shelving. As you saw, it's the same window as the committing, so you can also only do partial shelving and stuff like that. And then we have a new tab here where we had our log beforehand, which is shelf. So now here you would have all your shelves. In our case, it's only one. You can open it and see which files were changed. You also have, again, this handy button for the diff, so you can see what does this actually change. And then if you want to have it back, you just click this button. As you see, it's like the opposite of the one that has a downward arrow. Here you get it out of the shelf, right? Out of the box or whatever. And you can also stack them on top of each other. So if I now make another change, I can shelf this and it will also just add another line, another entry here. So if we do that now, we can click here and go on this unshelf button, and boom, our changes are back, and they're also staged such that we can either undo them now or do a commit or whatever. The shelf stays here by default. If you do not need it at some point anymore, you can of course do delete or rename it, also a bunch of stuff. Yeah, for now it's fine to stay here. The nice thing if it stays here is that if you for some reason mess up the file or lose this change, you can always at least bring the state of the shelf, which is this, bring it back always, which is pretty helpful. Yeah, that's that. I think this is all the basics you will need for getting started with Git and optionally GitHub in IntelliJ, or honestly any other programming environment. Let's quickly commit this, and as you can see, it now pre-fills the commit message. That's pretty nice, arguably, because of course it knew from the shelf already what is going on here. So we say commit, and here we go. Yes, one final word, since I know that I had this trouble, and you know that this channel is all about teaching you from my perspective how I learned. If you ever okay, no, it's nothing to make. Let's add something. If you ever commit and you want to like, oh gosh darn it, my changes are gone, they're not here anymore, what can be is this change list feature that I quickly touched upon. So you might have, in this case I don't have another one, but it might, if you use the native Git stashing, for example, it usually does another change list, or for example if you undo a commit. So it might be that you have like 10 change lists here, and the changes are split up over the change list. So don't worry if something is not here. It's very, very likely in the change list, which means you click on the arrow and browse around a bit to find it. The other thing you can do to do that a bit nicer is if you go on Git here and local changes, here will be all your change lists. So in this case I only have one, but if you have more, you can also consolidate them and stuff. So for example, if I have a change, there it is now, you can also say move to another change list, and then you can consolidate them a bit. So if you have one that you don't even need, you can all move them to like a default one, and then also maybe name this oops, no, not delete. Name this default or something. So it's clear what's going on here. Right, we don't need the change in here now, so let's roll that back, and let's also push, so we're sure that the stuff is backed up. Here we go, and that's it. The final thing I should show you, and there's no new things going to be added now, don't worry, is because I of course mentioned that this is just a user interface, and in the background for everything we just did, I showed you, it always executes the commands for you. So the alternative thing that you can do, this is not going to be part of this tutorial video, but you can find on the Git website, if you just search for Git project or Git website or something like that on a search engine. There's a lot of tutorials on their website how to use the command line interface. So what you can do is you go to terminal down here, or open it somewhere else if you know how to, and all the things we did, committing, pulling, pushing, stashing, etc., it essentially only always just executes a command. So we can do things like here, git push. So if you click this button, and that's something it's important to understand in my opinion, even though if you decide to not use this, since I personally don't use it myself even, because I don't know, honestly, this is more intuitive and ergonomic to use. Many people prefer this way, and that's up to you ultimately. I'm not saying use this or use that, use what you like. I'm just saying, personally, this is nicer, and I think the integration also here with the change and stuff is pretty helpful. What I'm just trying to explain to you, if you would say here, and as a matter of fact, let's just do it and do git push, what it just says is everything up to date, which is true. But what happened if we would click here on the green push button and then click push here, in the background it executes this command. It doesn't, I mean, it might add some like more options or something, but it just executes. It's just hidden away from you to, well, make it a bit more user friendly ultimately. The last word on this is that you can also always see this if you want to learn the command line interface a bit better, which has its merits, definitely. If you go here on the Git tab to the last one, console, which is the only one we haven't looked at yet, you actually see the commands it executes for you. So you can scroll all the way back where we started at some point. And for example, here at subtract feature, you can see it looks a bit daunting maybe if you're just getting started, but you see what it actually executes for you. So if you want to learn to use the text interface and not do everything with the shortcuts or even the icons here, the buttons, then this is a great way to check out what it does in the background. Or of course read a guide on the Git or any other website how to do that. I personally don't like it a lot, but it is helpful, let's say, to you at least know basic commands. Not to get started, but if you want to get more serious developing, then it is certainly useful, albeit not required, I would argue. All right, that's it at this point here in IntelliJ. Let's quickly go back to our slides and to the final words. All right, the first one I actually already touched upon just now. If you feel like it, it does certainly make sense to get familiar with the text-based command line interface of Git that ultimately is actual Git, right? That what actually does all the committing, merging, and so on. The other thing is there are other VCSs out there. Git, as I mentioned, is by no means the first one. However, in my personal opinion, and I think other developers will certainly agree here, it doesn't make a lot of sense to look at other ones. Git is by far the most popular nowadays, and if you don't have a specific reason, such as your future employer uses another one, or you have some friends that use this one and they don't want to use Git, then of course look at other ones, or of course if you're just interested. But personally speaking, neither when getting started, honestly, not even if you do it professionally, there's a lot of reason to look at another one. If not, it's out of curiosity maybe. And the final tip, really, that's the most important by far, is make sure to commit often and also push often enough. And as I mentioned, try to do it in like discrete, cohesive chunks. It's not a requirement. You can commit whenever you want. There's no rules or anything. But for your own sake, later to see the history a bit better of what went, what happened, and to be able to revert to like good points in time, it makes sense to commit like if you finished one feature or a part of a feature. You don't have to commit every line, but I also would not suggest to commit only if you added an entire file and wrote 1,000 lines in it, but a bit more often. Ultimately, you have to find a bit of a balance there. It's, as I said, it's everyone does it also slightly differently. But in general, when getting started, I would rather commit too often than too little. There's not really any downside of committing too often. And of course, make sure to also push. You don't have to do it after every commit, but every so often is good. Certainly, if you're done and you want to shut down IntelliJ or your editor and your entire computer, maybe, then I would just push, just to be sure. You know, you never know if it won't won't boot anymore next time. And then the work is always backed up. Yeah, that's it for this guide video. I hope you enjoyed it. Of course, importantly, if you do have any questions about Git that were not clear, or GitHub, or the IntelliJ integration, or honestly anything else about these topics, then please drop them in the comments. I will make sure to answer them. And finally, I just can say, if you like this, make sure to subscribe and hit this stupid bell icon, right, to get newer videos that I'm gonna upload. There's many in the pipeline at the moment. And make sure to like the video and share it with anyone else that you think might be interested. That would help me a lot, of course. Yeah, that's it. Any feedback, as always, please leave it in the comments as well. And finally, I can just say thank you very much for watching, and I see you in the next one. Bye-bye.